Okay, so moving on, we are going to go to number 7 now. This is the second part of the ionic bonding review. So number 7 says, write the chemical formula of the following, and then gives several different compounds. So to do this, we just have to go over a few naming rules. So if we were to look at a couple naming rules, we first have to realize that the cation goes first. Cation, and then the anion in naming. So sodium hydroxide. So sodium is the cation. We could also see that if we looked again at the periodic table, see that it only has one valence electron, so we'll give that valence electron away, and will become 1 plus. The cation in this case is hydroxide. We could scour the entire periodic table over and not find hydroxide. That's because it is a polyatomic ion. It's one that we should have memorized. So OH minus. When we do this, we want to put parentheses around OH because they are a group of atoms that are going to be acting as one ion. They're a group that's going to be acting as one. So now if we have this situation, we could ask how many hydroxides will it take to satisfy the positive charge on the cation? And the answer is 1. The reason why is there's 1 positive here, 1 negative here. So in order to get to 0, you just need 1. So the formula for this is NaOH. Another way you could have done this is saying Na positive and OH minus, do the crisscross method, and you'll get NaOH. Let's try looking at a couple more as well. Let's look at C. C is iron 3 chloride, oxide, iron 3 oxide. So the Roman numeral 3 here indicates the charge on the iron. Iron is one of those elements that have multiple cations that it makes. Iron can make iron 2, which is Fe2+, or iron 3, which is Fe3+. This 3+ is shown by the Roman numeral 3. If it was iron 2, we would just see a Roman numeral 2 there in that case. So in this case, we're going to use iron 3+. So we write down iron 3+, and oxide, if we know the naming, oxide is the anion of oxygen, which is O2 minus. Oxygen has 6 valence electrons, so in order to get to its octet, it wants to gain 2. So when it gains 2, it becomes a 2 minus. So if we have this situation, we'd say how many irons does it take to satisfy oxygen, or vice versa, how many oxygens does it take to satisfy irons? Now this is kind of a weird situation where it's 3 and 2. If I was to give 1 oxygen to iron, there would still be 1 plus left. And then if I was to give another one, there would be a 1 minus. So we have to look at we have to look and say, okay, if we were to do the cross rule, we'd have Fe2O3. But how does that work? Well, we could look and say Fe has 3 positives, and another Fe will be 3 positives. O has 2 minuses. Another O has another 2 minuses. Another O has another 2 minuses. So let's count up our charges here. So total here is 6 plus charges. And total here is 6 negative charges. So that's what it takes in order to satisfy these two. It takes 3 oxygens and 2 irons. So moving on to question 8. We kind of just discussed that a little bit in this last question. But we want to look at naming. So there are a few different things we have to think about when naming. We have to think about the cations, the anions, metals. Are they transition metals that require Roman numerals? Are they polyatomic ions? And all of these things are going to go into the name. So let's look at letter A. Letter A has this PbCl4. If we were to look at the periodic table, we'd see Pb is lead. It turns out lead is one of those elements that can have more than one cation. So if we can think about this and think that at one point it was crossed down like that, so this will just come back the opposite direction, and this one as well. There's essentially a 1 here, so it comes backwards. We have lead 4 plus. How do we know it's the lead's 4 plus and not 4 minus? Well, that's because it's listed first, so it's the cation. And then we also see that this moved back, so chlorine is a 1 minus, and that makes sense because chlorine has 7 valence electrons, only needs 1 more to fill an octet, so we'll take 1 electron, become Cl minus. Okay, so how do we name this? This forms more than 1, so we have to say lead 4 and to name anions we have to change the ending to IDE, so it changes it to lead chloride. So we whacked off the ene and added the ide, so it turns into lead chloride. Let's look at something like E. E will be a very interesting one for us. So we have calcium and something that looks like a polyatomic ion. So when we look at this, we should be able to look at our polyatomic ions and recognize what that is. And that is permanganate. And when it comes to these, it's pretty straightforward. When naming polyatomic ions, all we have to do is just say calcium, and then we don't have to change the ending of polyatomics. They're different, so we just say permanganate. Calcium permanganate. That's all you have to do for that. Because this 2 comes back, calcium's a 2 plus. It doesn't have any other ions that it makes, cations that it makes, and so it just is calcium permanganate. Okay, let's look at one last one. Let's look at K. K is an odd one. I think that zinc actually, so the formula is zinc 3 PO4 2. So I think zinc is not one that you have to write down the Roman numeral 4, but it's in the D block, so let's just do it anyway just to be safe. So we'll say zinc. This crosses back. This crosses over too. So we're left with zinc 2 plus and PO4 3 minus, which is our polyatomic ion that we recognize as phosphate. So to name this, we would say zinc 2 phosphate. Okay. So for this last part, let's just check our understanding with questions 9 and 10. So question 9 says a class may insist that sodium gains a positive charge when it becomes an ion because it gains a proton. Explain the student's error. So the error in this is that we are not dealing with protons. We did that in chapter 25 back when we were talking about radioactive chemistry. So we're not even talking about protons in this case. It's all about electrons. The only way we can get a positive charge is if electrons go away, and the only way we can get a negative charge is if electrons come in. So with the positive charge, there are no movement of protons. If that was happening, we would be having some sort of nuclear decay. Okay, for the last one, let's look at A for this as well. It says KCl2. What is wrong with this? Well, if we switch these back, let's dissect it. So it's saying that this crosses up, so it's going to be a 2 plus there, and that crosses up, so Cl minus there. Is that truly the case that potassium is a 2 plus and that chlorine is a 1 minus? We've looked at chlorine quite a bit. It has 7 valence electrons, and it only needs one more electron to gain that octet and the full electron orbital. So yeah, it will become a -1 anion. But what about potassium? Is it a 2 plus cation? If we look, it's in the very first row of the periodic table, meaning that it has only one valence electron. So when it gives up that one valence electrons, it then has its octet and will mean it's a +1. So that's the error, is that this should not be a +2. The true formula for this would be K positive and Cl minus. Those would cross. So it would just be KCl. Okay. There are also 5 different properties of ionic compounds that you need to go over. A few of these are that they are hard, brittle, they have really high melting points, they do not conduct electricity in solid state, but they do conduct as a liquid or dissolved. Okay, so that finishes up everything from the review. If there are any other questions, you can post comments on the opening page of my website. That is lamphysicschemistry.weebly.com. Okay, have a good day.